Alright, so regex is super cool. If you haven't used regex before, then it's gonna be quite difficult. But let's say, there are multiple flavors of regular expressions. There is the PHP version, the JavaScript version, the Python version, and the Golang. No, that's new. The Golang version. So what is regex? Let's go to Wikipedia for that. Regex is a sequence of characters that define a search pattern. Okay, the search pattern is the keyword here, and it looks a bit like this, with a lot of characters. So what Steve was doing earlier was trying to find the temperature, humidity. Let's just go with humidity. So let's say that my test string is humidity, and I'm going to have multiple versions of humidity. Something like with a capital H, with a capital D and Y, R in the middle, and you want to be able to match, and also with a bunch of spaces before and after the string. And so what you want to do is to be able to detect humidity in all of these variations. How do you do that? Well, the first thing you want to do is probably just type in humidity in the search pattern. And so as you can see, it can detect basically the first case and the last case, because it doesn't have any capitals on it. Oh, this tool I'm using is called Regex 101. Great tool to learn regular expressions and to test it out as well. So this is a case of case, lowercase, uppercase. So there's a flag that you can enable as well, which is to ignore all cases, case insensitive match. Turn it on. Voila, you match every single case, and you don't have to do any extra work. Now, why is there a different flavor for JavaScript, Python, and Golang? Well, at the very base of it, there are multiple implementations of the regex standard or specification. So on Perl and Ruby, you have the widest coverage of all the features of regex. Then on JavaScript, there's a bit less, and on Python, it's very close to Perl and Ruby, but they also add support for, they add really good support for Unicode. So you know how the different double quotes. There's this double quote. There's also, I don't know how to do this in a Mac. No, basically there's multiple versions of double quote. Like the curly double quote, the straight double quote, the coding double quote. It can detect all of that in Python, but your experience may vary in JavaScript. That's a biggie. Alright, so let's get to the main topic for today, which is going to be ESP32 and also Watson text-to-speech. A couple of days ago, I bought myself not a couple of days ago, a couple of weeks ago, I bought myself an ESP32 Lyra T development board. Looks a bit like that. This in real life. Zoom out. Yep. So what it has is an ESP32W Rover-B, and what it has more than a usual. Let me see if I could find one. ESP32 development board is, I couldn't find one. That's alright. Is that it has more PS RAM. Just basically more RAM. You can do more processing intensive applications on the Rover-B module. And then in the middle of this board, it also have a really inexpensive ES8883, I think, audio codec chip. Can I scroll down? No, I cannot. I wonder. Hey, thanks for following Vinny Cluster, CSDev. It's a audio codec, so it can have multiple microphone inputs and multiple audio output. And on the same board, there's also a micro SD card reader, some switches, and a lot of capacitive touch buttons. So play, set, volume down, and volume up buttons. There's some boot and reset buttons over here, and there are some extra buttons for record and setting the mode. The only downside with this board is that because it's an audio processing board, it requires extra power to power this board. So there are like two separate USB USB micro B inputs that you need to power it up. So what I have is two USB. How is it looking? Yes. Oh my. Oh, that's interesting. So I do have two USB micro B cables. I just haven't plugged it in, so let me plug it in now before I switch it on. There's a power one. I'm going to use my power USB for that, which is light up, and then plug in the other one for the UART. Oh, and for this stream, it's going to be a lot more technical compared to the previous streams. So if you got any questions, just pop it into the chat and I will respond when I see it. Alright, so it's light up now. I also have the board hooked up into my audio interface. So I have already preloaded this board hooked into Watson text-to-speech, and it's gonna say all dogs go to heaven. And let's see whether I can actually get it to work or not. Enabling the microphone and the board. Yep. Okay, so my audio still works. So if I reset this board, reset. There's be some intermittent audio. I wonder if you can actually. Oh, I forgot to hook up the audio input cable. So let me do that again. No wonder why I couldn't hear it. Alright, the noise at the background is because of the non-unshielded cables I have with me. So let me just reset this board. Reset and wait. And we're gonna show this in action as well when we start to go to the coding part.
All dogs go to heaven.
Did you hear all dogs go to heaven? Alright. I assume that's a yes. Alright, so how does this work? Is my voice still coming through? Yes, my voice is still coming through. So the ESP32 LARA board has an SDK called ESP-ADF, or Audio Development Framework for short. At the point of this recording, this particular framework isn't available in Arduino platform yet. So you have to do a lot of C with this. But the cool thing about it is that you don't have to program, so there's a release feature, you don't have to program in any audio codecs for FLAC, MP3, AAC, or whatever. It's all handled for you out of the box. Right now, they have support for, partial support for Google services, Amazon, AWS Lex, and as well as Alexa. A lot of things. There's no Watson IBM on this, so as I bought the board, I tried the interface with Watson text-to-speech and speech-to-text. Got the text-to-speech to work quite well, but not the other services yet. And today we are just gonna go and see how to do this. Right. So I have a GitHub repo, Watson TTS ESP32 LARA T, that summarized how to like clone the code, how to configure the code, and how to flash the code onto your board for this to work. I'm going to pop the link into Twitch as well. Yeah. So let me go to my studio code. So let me walk you through how this is probably going to work best. When I was coding this sample, I intentionally put each section, like each working version, into Git, so it can form like a tutorial for you to go through. So on Visual Studio Code, there's this really cool, Espressif created this really cool extension called Espressif. This should just work. Espressif IDF, which is the IoT development framework for ESP32. And what it does is it enables the different C and C++ properties that just point directly to the path, pull out the old include.h header files and load it onto Visual Studio Code for you to work with. So for example, if I command or control hover over this particular symbol, and click on it, it will navigate to the source file, which is fantastic, and we never really got this before until a few months ago. And you can also, if you do Control-Shift-P or Command-Shift-P on a Mac, you can create a new ESP IDF, create a new project, and it will instantiate a boilerplate project in Visual Studio Code for you. And that is exactly what I've done here. I've cloned the Git repository Watson TTS ESP32 Lara T. Lara T is the board name. Onto my local computer. I've got it in, where's my EVS code? I've got it in this folder, Watson -TTS, and I have checked out the very first commit, which is this one. Copy, create a new ESP project, git checkout, and put in the hash number in there. Voila, you're now at this particular branch, created a new ESP project. And this is what the default project looks like. You have your main.c. Again, this is a very C intensive stream, so well, session. If you don't get C, it's gonna be quite hard to follow along. So yeah, your headers, basically you include, you have an app-_main. So why isn't this main like the normal main function? It's probably because we're using a pre-packaged framework. So ESP is already have a main.c somewhere, and it's just configuring all the compilation for you out of the box. So to get to this step, I assume that you are an ESP32 user and that you have already set up your toolchain. So if you haven't, the easiest way is to go to Espressif IDF documentation. I'm using the latest version as well. They have a release version for version, what's stable version? It's I think 4.0.1, and just using the master branch right now because it has the best support for the IDF framework. So the way you do it is just follow the instructions on how to set IDF first. You need to do the IOT development framework first before you attempt to download and install IDF. So on the Espressif IDF website, there's also a getting started page. Is there? Pretty sure there is. What's this one? Yep. This is documentation for the IDF. There are also some installation steps, step-by-step installation. Voila, fantastic. During this session, I'm going to be using some different commands that help me to not having to type a lot of code, and these are saved in my bash profile. I have the IDF path set up to the IDF folder. IDF path set up to the IDF folder. I have a command called get_IDF that export all the environment variables into my current shell. I have the list IDF examples that prints out a tree of the IDF path. So let me just do that so you can have a idea of what it looks like. Voila, a tree. Tree is an awesome COI command. Just basically lists everything. I'm setting the level to 2, so it only go like 1 level down instead of everything. The last thing is I list all the ports that is connected to my Mac. This list as a list using order by time and reverse. So the newest entry is gonna show first. And this is the regex. Yeah, that's right, Steve. Regex search pattern that we use to match the ports to what we want to search for. So on Linux, it's going to be -dev-tty, and on a Mac, it's going to be -dev-cu, just a fundamental difference. So if I try to just run ls-ftr dev-cu.o, then you're going to see a device called slab_USB to UART. SLab stands for Silicon Labs. They are the company that produce the USB to UART chipset, and that is the port that we are going to be using primarily for when we flash the device. So if I also run these ports, it should have the same results, or maybe with extra TTY. Yeah, it also have TTY. For some reason on the Mac, TTY just doesn't work. I think it's a design issue. Not issue, just a design feature. So those are my extra aliases and commands. Let me quit out that. Cool. So how does this work? So when you develop for a new platform, especially for something like embedded, not new per se, but more like myself, I don't want to start from scratch, because you have to understand how it works. And it's really helpful that the manufacturer, that is Espressif, has come up with at least examples that allows us to get started quickly. I think I have examples as well. Oh yeah, that's right, I have at least IDF examples. So if I navigate to my IDF path, there's example folder. So the examples. Oh no, I want to stick at the IDF. Sorry, that's IDF path. Examples. I want to get IDF examples. Examples. Tree. So if you print, say, tree just by itself, it's gonna list everything. So you only want to show the tree for maybe 1 or 2 levels tops, or just open it up in the Finder on the Mac. Yep. So as example, there's a get started, and it's gonna play an MP3. Excuse me. Play an MP3 with some preloaded audio. What is that? This one. So IDF Music. Fantastic one to get started with. The example project that I base my project upon is actually under cloud services under the Google Translate device. A lot of the code in my example is copy and paste from the Google Translate service, copy and paste it from the get started example, and also I think the pipeline HTTP to MP3 examples, they're fantastic to work with. Alright, let me just go back to my project. This thing is on ESP. Watson TTS. Yes. Cool. Oh, I have to click on open as well. Alright, alright, let me just jump directly to the latest. Oh, another thing is, if you have existing ESP32 project and you want it to just work with the latest compiling the code assistant features of Visual Studio Code, you can create a new ESP IDF project with the command, and then copy and paste over the c_cpp_properties.json. And this is what I've done here. I published the Mac OS and Windows versions of these files onto my GitHub gist. It includes the include paths for IDF and ADF, and how you can get those include files into your project. So how does this project work? So I just realized just now is that if I really want to go through step by step on how this thing is gonna work, it's gonna take at least 3 hours. So to save time, I'm just gonna jump straight to the part where you would get something to work. Post now works correctly. It sounds like oh, maybe not this one. No, actually just to walk through how it works. So after you created your ESP project, I'm gonna push it to the side. You need to change the project name from the default to something else, and the way you do that is in your CMake list file right here, project template. By default it's a template dash app. You can change back to anything else by just renaming this, and that is exactly what I did. Oh, it's not letting me copy. Key checkout, the hash, voila. Change to Watson STT dash TSS TTS. I was actually gonna do this for both speech to text and text to speech, and then it turned out that I couldn't, or just didn't have enough time. And after that, you would add in your IDF path. So by default, the Espressif IDF plugin for Visual Studio Code do not support IDF out of the box, and you kind of have to add it in by yourself. And the reason why you would like to add it in would be to get the code hinting. The only file that's changed here is this. So I add in the environment variables for the include path, as well as the browse path for the different C files and header files. Right. So when you create a new project, there's gonna be a lot of printf. There's nothing wrong with printf. It's just that there are some extra functions in the ESP32 IDF framework that give you a bit more control over your log files, and those are called ESP log. Fantastic little thing. Refresh. Nope, not refreshing. What did I do wrong? Oh, good check out. It's called ESP_log, and then it also includes the severity or the level of the block. So a lot of these is like log I means just log information, and then there's a tag. So this tag is a Watson TTT, basically just an arbitrary tag. And the way that it shows up in debugging is it looks a little bit like this. It looks a little bit like this. Sorry, how do I zoom in? So you have the I, which stands for information, the E stands for error, the W stands for warning. You have your tag, right? In the example repo, I've changed it to Watson_TTS. In this particular version or commit, I have Watson STT TTS, and that's gonna show up here. And then you have your message showed up next to it. So this makes debugging a lot easier because it's also color-coded. Yep. Oh, so after you set your tag, you need to also set the level in which you want the program to print out. So I have set this particular tag to print out. The lowest level is going to be debug. And the way that this works, oh, nope, is that it compare. So each of these is assigned with a number. And if the current set level is either greater or less than this particular number, it's gonna not show up or show up. Yep, and sprinkled throughout, I have a lot of information logging, info logging that just prints out the actual information that I need. And you need to be familiar. So this is also based on printf. So whatever works in printf is gonna also work in ESP_log. Alright. And next one, oh, so massive. Next one up, we want to connect to the Wi-Fi with some default configurations. So for this particular commit, I put in my guest Wi-Fi password directly hard-coded in the code, or something that you don't want to do. And you can do that by creating a different kconfig file, which I'm gonna go into a bit later. And then for the next several commits, what I do is I copy and paste over the code from example projects into this project to make sure that I understand how things work and that it works for my board as well. Yep. All this steps, just change the file. So for example, just the way how this works is that 1.1 corresponds to the stage 1.1 under here. So in stage 1.1, the logging, I needed to add ESP log, ESP Wi-Fi, flash, peripherals, and the Wi-Fi peripheral header files for this particular example to work correctly. So when you see the squiggly line, that sounds wrong, under the different header files, what that means is that Visual Studio Code cannot find the header file attached. And the way you can fix this is rebuild the project. So the first thing you need to do is you need to export the path and the different environment variables, and then run idf.py build, and that should build, which it doesn't. Alright, I'm gonna have to full clean this. A bit unfortunate. That's probably because I have been reusing a project. That might be why. Building. It should build correctly. It's already been tested. Yeah, there are a lot of files this thing needs to build. About 1,000 worth of them. Right. Also, in this project, you're basically bringing in the HTTP stream that is gonna decode the stream and send that to the I2S stream that the audio codec chip will receive, and then HTTP. Then you need to decode the stream, the MP3 into some I2S protocol, and then stream it onto the audio codec. That should work. And down here somewhere, this is how you connect things up. You register the individual component, the stream reader, the MP3 decoder, and then write it to the I2S stream, and link it up with this function audio pipeline link that passes in these 3 tags for the different components. When that is done, you will start to read the documentation for Watson text-to-speech. One thing I found about Watson text-to-speech is that the documentation doesn't come up as a first result on IBM documentation. So another way you can do this is go to cloud.ibm.com, go to catalog, search for text-to-speech. Yeah, there's a lot of searching involved. And go to API docs. And voila, you have the API docs for this. Yep. So let me just go to this commit, git checkout. So for this particular commit, what happened is I have Watson text-to-speech to synthesize. The Pomchi is a mixed breed dog across between the Pomeranian and the Chihuahua dog breeds, playful, devoted, and energetic. These small pups inherited some of the best qualities of both breeds, which is rewritten for Watson TTS. We need to initialize it. Synthesize is basically to bring text into an MP3 video audio stream and get the message back and send that to the I2S stream. So in this particular example, I'm just using the get statement. So with Watson text-to-speech, there are 2 ways you can synthesize audio. The first one is to use a get method. It's a bit simpler, but you have to include the authentication in the get request itself, so it's a bit less secure. Or you can also use the post request here, post and get. So to get this started super quickly, I use the get request, and that worked perfectly fine. Where's my window go? Yeah, there it is. But then later down the line, I realized that I would love to make this a bit more secure, and to make it, I need to start to explore how posts work. Yeah, it got way more complicated from here. So the good thing about a framework is that if things are working correctly, you don't have to delve into the internal working of things. But to handle a post request, especially when you're working with the ESP IDF framework directly in C, you need to do a lot of manual labor on how to get this to work. And I can't wait for the Arduino ESP team to pick up IDF and get it to work in their internal systems. Yeah, so a lot of code to handle the different events that come back from the post request. And after that, once the post request starts to work correctly, then I expose the API key authentication config in kconfig. So if you haven't seen kconfig before, let me show you how it looks. It looks amazing. Yeah, I'm in the right folder. Oh no, project build completed to flash from this command. Yeah, that's fantastic. So let me just do a full clean again because I just cloned a new branch. I'm going to go to rdf.py menu config. The menu config is like a visual configuration screen for the CLI. It's very nice to work with, and you can even expose custom menu items by creating a file called kconfig.project_build inside your main folder, exposing different configurations. So for example, in this example, I have the Wi-Fi SSID and the Wi-Fi password in the kconfig file with some IBM Watson configuration as well. And voila, you have the same thing in here. So you have your Wi-Fi password with my guest Wi-Fi, as well as the Watson configuration. So you need to put in the endpoint, you need to put in the authorization encoded in base 64, and you need to put in the Watson text-to-speech voice for your application. And after that, you're just exposing the kconfig as a readme, updated readme, and fix the license for the project. Does it sound complicated? Yes, it does sound complicated. Because it's a lot of C. There's a lot of time that goes into this to make it to work. A couple of points on the API key part and how you can find that out. So if I go to my IBM Cloud, let me just bring this to another screen so that you don't see my passwords. It's not like it's gonna be seen publicly anyway, but I do have to log in through SSO. Oh, look at that, I have to log in through SSO. But I need to be in the right account. Just loading. Oh, there it is. Let me show you how you can find your API keys. So after you have created a resource, select text to speech. Select your region. I'm choosing Sydney for now because I'm in Sydney. And you can set the light plan, which is free, and you are only limited to about 10,000 characters a month, not words, characters. Once that is created, you have a new service inside your resources list. I'm going to go to services. I'm going to go expand services. Fantastic, thank you. Text to speech in Sydney. Yep, and you get your API endpoint, which is just this part right here. And you can also get this, excuse me, in the documentation. And this is your API key. So let me, how do I show, yes, show credentials. So my API key is a string. And the way that you would pass this into this particular project is to copy the string. I need to base encode this, encode. Yes, let's do this online, and everyone can see my key, API key, and encode, which is, this is my encoded by 64. API key is a username, and the password is my API key. The password is my API key, which is that really long string. And once I base encode, and once I have put them together with a colon in between, encode it, and you can put it into your kconfig file, or kconfig, by pressing enter, deleting the XYZ. You need to also put basic in under prepare to as basic, and the reason for this is because we're using basic authentication. Now let me show that inside the documentation so you know what I'm talking about. Go to post. Oh, example. Post API key, the actual API key. Enable content type application JSON to be the one of the header. Accept I'm using MP3 audio-MP3 for this, and just put the text here. So let me show you the corresponding code for this as well, so you know I'm not lying. Yeah. So the endpoint, synthesize that voice, just like here, synthesize $voice equals to, they use Allison version 3 voice. I used a voice config in my TCS, which is the British one, further more sophisticated. Yep, so I enable my content type, enable accept to be MP3, and put in the authorization header as the base 64 configuration string. So in here, just put in my super long string. Wait, no, it's gonna get done. Oops. Oh my, oh dear. So I can press enter to not save anything. Space, put it in, enter, save it. Get out, save. S for save right here. Where do I want to save this? I want to save that to there. Enter, exit the file. And if I just clean it and build it, it should pick up the new configuration files, and that should work just fine. And I know it's a bit long, but I think I already showed the demo at the start. So you can change the text to be said somewhere in main.c. Did I put it in main.c? Yes, I did. I call the function here Watson TTS Synthesize, all dogs go to heaven. And then when the audio pipeline is finished, they will stop the audio pipeline, destroy the actual instance to save memory, stop the peripherals, remove the listeners to the audio interface, and just go to sleep and shut down essentially. Yep. So if you're keen to help me get this to work for Watson speech to text, hang on, yeah, speech to text. So there's also a tiny, not sure you can see it yet. Oh yeah, tiny microphone just right there, I think. Yeah. Oh no, two tiny microphone over here and over here that allows you to speak to the board and try to get some sort of services to run and work. And there's also a, as I said, a micro SD card slot for you to record your voice and do some audio transcription that way as well. But yeah, lots of things to do, and some of the things I'm hoping to do next is A, get speech to text to work, and also B, try to get the Arduino ESP32 team to take in the ADF framework, the audio development framework, and just get it to work correctly. Yep. Thanks for listening in, guys. At about 7:30 p.m. today, we are going to have Ali and Gloria, who's going to be doing a trivia game overnight. Not overnight, sorry, from 7:30 to about 8:30, I think. With that, there's a lot of prizes to be had. There's some t-shirts, there's some ESP32, not this one, they're like just the normal ESP32 boards. There are some socks, stickers, security card holders, and I think pop sockets that Steve also has. So tune in at 7:30 tonight, and I will see you guys then.